Okay, briefly, who I am and why I'm here. I am a former engineer from the military space program. I entered that program a number of years ago as an evolutionist and an atheist. I came out of it a creationist and a Christian. And tonight I'm going to share some of the things I learned during that time and since, and try to convince you of my beliefs now as well. See, so I'm going to indoctrinate you. But I'm warning you up front, so it's ethical, right? You've sometimes been told, I'm sure, as I have, that we're creationists because we're Christians. In other words, if we weren't hampered by our Christian beliefs, we would see the obvious truth of evolution. I am one among many who, for the opposite is true. I became a creationist first and a creationist after. So what I'm going to talk about tonight, and the time we have, is, as you can see, our created solar system, what you are not being told about evolutionary astronomy. Let me explain my use of the word evolutionary first. Most people use the word evolution to talk about biology. That's, of course, the most common use of it. You also hear it applied to other objects as well that aren't based on life. So when I talk about evolution, I'm talking about the idea that everything around us, the entire universe, formed all by itself without the intervention of a creator. If I can figure out how to work this thing. Click. Now, there's two opposing views as to where the universe came from, the Bible versus the Big Bang. The Bible says everything was created in 6 days, about 6,000 years or so ago. Every object in the sky was created for signs and for seasons and to glorify its creator. The Big Bang, on the other hand, says that everything formed all by itself billions of years ago with no creator necessary or desirable. Everything is explainable by current theories. Now, the basic theme of tonight is that although we are told constantly over and over and over again that science has it all figured out, that evolution is the answer, that there are no problems in this theory whatsoever, I'm here to tell you that's not true. We're going to talk about a lot of the problems, I shouldn't need to say a lot, some of the problems that exist in an evolutionary view of astronomy today. As you can see, I have a picture of the solar system. This is not to scale, of course. In reality, it would be spread out much further. Obviously, there's a sun in the middle. Going outwards from the sun, we have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and out here is the orbit of Pluto, Pluto being the furthest from the sun. We're going to limit our talk tonight to these objects. There's a lot more within astronomy we could talk about, obviously, but this is all we have time for tonight. We're going to go through each of these planets and show that each one, in a unique way, disproves evolution. And when you are being told that evolutionary astronomers have it all figured out, well, you can judge for yourselves what to think of that opinion when we're done tonight. The standard model, according to evolution, says that our solar system formed billions of years ago from a large swirling cloud of gas and dust. This cloud is usually called a nebula. Thus, this is called the nebula theory. You might hear that phrase being used. So the nebula began to rotate as it was swirling. As it rotated, it also flattened into a disk. A central bulge in the middle formed as it was rotating and became our sun. Smaller collections of material around it then became the planets. So here's an artist's conception of what this might have looked like. Is there a way we can lose the dinosaur, Bruce? Am I doing something wrong?
I think you must have. Oops. Here I go. Okay, you want to go back?
Thank you.
Okay.
Yeah, galloping dinosaurs aren't really appropriate, but that's Saturday morning, right? The dinosaur talk? Yeah. Okay, so here's an artist's conception of what the early solar system used to look like according to evolution. You see there's this big swirling cloud of gas and dust. There's the central bulge in the middle, which is already forming into a sun. Notice here there's rocks forming. I'll talk about that in just a minute. Notice also that this whole thing is a flattened disk. It's no longer a big circular cloud. It's flat and rotating around the forming sun. Now, as this gas and dust coalesced, larger grains of dust formed within it. These stuck together to become rocks. And the small rocks stuck together to become bigger rocks. And the bigger rocks stuck together to become what are called planetesimals. That's a word that you'll hear a lot in astronomy, but not really anywhere else. So I'm going to use the word asteroid tonight when I talk about planetesimals, but it basically means big rock in space. So the asteroids formed from the smaller rocks, and they stuck together to become planets. So that's where the planets come from. And here's an artist's conception of a later stage in that process. You see we have a nice sun out here, we have a nice planet here, and there's still a lot of rocks forming, in some cases colliding with each other. But eventually they all stuck together and they all became planets, and that's where we all came from. So this basically is the hero of the story. This is a real asteroid in space today, but I'm going to use it for illustration of what a planetesimal looks like. One of these early rocks that isn't quite a planet yet because it still needs to stick together with a couple of its brothers and make planets. So, basic idea is gas and dust stuck together make rocks. Rocks make bigger rocks. They eventually turn into these things, asteroids basically, and then the asteroids stick together and become planets. Well, there's only one problem with this model, and that's it doesn't work. Oops, I'm getting ahead of myself. Okay. Evolutionists will tell us that proof, quote unquote, for this model is that the theory explains the flat shape of our solar system. I showed you how everything turned into a disk, and indeed in our solar system today, all the planets do rotate or orbit around the sun in a disk sort of shape. Obviously there's no physical shape there, but you know what I'm saying. All their orbits, with the exception of Pluto, which we'll talk about, all line up with each other in what is called the plane of the ecliptic. So this model explains the plane of the ecliptic and the fact that all the planets' orbits line up with each other. It also explains the fact that all the planets orbit counterclockwise around the sun. It also explains the fact that the inner planets closer to the sun are rocky, whereas the outer ones are made of gas. Part of this model says that the closer you were to the sun, the hotter it was. Well, that's not brain surgery there. But the higher temperature made it impossible for water and volatile gases to condense. Thus, the only things that could condense out of the cloud close to the sun were rocks. The further away you got from the sun, however, the cooler it got, and so you can have larger gas planets like Jupiter and Saturn and so on. Is everybody with me so far? Or am I getting too detailed? Okay. Minor detail with this whole model is that it doesn't work. You can model how gas and dust will stick together to make bigger grains of dust, and you can maybe even get small rocks out of it, but you can't get the planetesimals to stick together into planets. Here's a quote as an example from a man who actually believes this model. Once these planetesimals have been formed, further growth of planets may occur through their gravitational accretion into large bodies. In other words, the planetesimals, after they get big enough, start having their own significant gravitational field, and as they pull on each other, then they'll accrete, they'll stick together and make planets. But just how that takes place is not understood. So incidentally, this is from an astrophysics textbook on page 553. So you wade through 500 pages of all the dust and the grains and all the rest of it. Then you get to the part where the miracle happens. And then we skip on and go something else. So it makes you feel that your first 500 pages have really been a waste of your time. But we'll skip that. Now, let's look at the evidence without preconceptions as to whether or not evolution or creation or whatever happened. And we're going to ask the question, with all the things we actually see in the sky, I mean, throw out the theoretical models about what may have happened. Let's look at what's in the sky right now and ask which model do these things support. Do they support the idea that a solar nebula formed from gas and dust billions of years ago? Or do they support a more biblical model which says that the solar system was formed recently by an intelligent creator for signs, seasons, and to demonstrate his own glory? We will start with the planets closest to the sun, called terrestrial planets because they're like Earth, they're rocky and not the big gas planets. We have Mercury, Venus, Earth, and Mars. We will take them one at a time. We'll start with Mercury. Mercury is the closest planet to the sun. It's tiny. It's smaller than all other planets except Pluto. It's even smaller than Ganymede and Titan, which are moons of Jupiter and Saturn. Being so close to the sun, Mercury is a rather hot place. If you are on the side facing the sun, temperatures get up to 840 degrees Fahrenheit. On the other hand, if you're on the side away from the sun, temperatures go down to minus 180 degrees. So very big temperature differentials there. Now it looks a lot like our moon. It's small, it's rocky, it has impact craters from where things have hit it, and so on. This picture here, incidentally, is colorized. All of our photographs, for the most part, came from the Mariner 10 space probe, which took black and white pictures. But from subsequent analysis, scientists have figured out that if we had taken color pictures, they would probably look like this. The streak here, by the way, is a spot where we don't have photographs for. So that's not actually part of Mercury. So here's what the planet looks like. Now let's see how well it fits with the evolutionary model.